This is SpaceTime Series 24, Episode 80. Coming up on SpaceTime, could mystery methane plumes discovered on Enceladus be a sign of life? Astronomers may have finally detected evidence of plate tectonics on Venus, and the Earth hit by a powerful Xclass solar flare. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study suggests that methane detected on the Saturnian ice moon Enceladus could be a sign of life. The methane was detected by NASA's Cassini spacecraft in icy plumes erupting from the frozen world's South Pole tiger stripes. The geysers are spewing water from a global subsurface ocean, kilometres below the Enceladian ice sheets. Cassini detected relatively high concentrations of methane, dihydrogen, and carbon dioxide, all molecules which here on Earth are associated with hydrothermal vents on mid-ocean ridges. And many scientists believe that at least on Earth, the mid-ocean ridges may be where life on this planet began. The amount of methane found in the Enceladian plumes was especially unexpected. One of the study's authors, Associate Professor Regis Ferrier from the University of Arizona, wanted to know if Earth-like microbes, known as methogens, which eat dihydrogen and produce methane, could also explain the surprisingly large amounts of methane detected by Cassini on Enceladus. Ferrier and colleagues developed mathematical models to calculate the probability of which different types of processes, including both geochemical and biological methogenesis, could best explain the Cassini observations. Their findings, reported in the journal Nature Astronomy, conclude that the Cassini data is consistent either with microbial hydrothermal vent activity or alternatively with a process that doesn't involve life forms but would have to be very different from ones known to occur here on Earth. On Earth, hydrothermal vent activity occurs when cold seawater seeps into the ocean floor. It circulates through the underlying rock and passes close to a heat source such as a magma chamber before spewing back out into the ocean again through hydrothermal vents. On Earth, methane can be produced through hydrothermal vent activity, but at a very slow rate. And most of the production is due to microorganisms that harness the chemical disequilibrium of hydrothermally produced dihydrogen as a source of energy, and produce methane from carbon dioxide in a process called methogenesis. The authors looked at Enceladus' plume composition as the end result of several chemical and physical processes taking place in the moon's interior. The results suggest that even the highest possible estimate for geochemical methane production, based on known hydrothermal chemistry, simply can't explain the methane concentration measured in the plumes. However, by adding biological methogenesis to the mix, the authors could produce enough methane to match the Cassini observations. This is SpaceTime. Still to come, astronomers may have finally detected evidence of plate tectonics on Venus, and planet Earth hit by a powerful Xclass solar flare. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, I Know What Scares You. Have you ever seen a ghost or UFO, had a premonition that came true, or experienced something that you simply can't explain? On I Know What Scares You, celebrity guests and listeners share weird, true stories of their own real-life experiences with the paranormal, the inexplicable, and the simply terrifying. Then a crack team of experts, including Skeptoid's Brian Dunning, anthropologist Natalia Reagan, and Dr. Kiki Sanford, host of This Week in Science, take their best science-based shot at what they think really happened. Was it an optical illusion, your brain playing tricks on you, or truly a mystery? Find out on I Know What Scares You. Subscribe now to I Know What Scares You on Apple Podcasts, Spotify, or wherever you get your podcasts. And now, it's back to the show.
This is SpaceTime with Stuart Gary.
Astronomers may have finally detected evidence of plate tectonics on Venus. A report in the Journal of the Proceedings of the National Academy of Sciences claims there's evidence of crustal blocks on the planet's surface which appear to have been jostled against one another like broken chunks of pack ice. The Earth is the only known planet to experience tectonic plate activity. Earth's plate tectonics are characterized by mid-ocean ridges of sinuous mountain ranges where molten material from deep inside the planet flows out onto the surface where it cools and hardens into rafts of rock, drifting on the top of the slowly convecting mantle until it reaches the lighter continental crust, where it subducts back down into the mantle and is heated up again. Worlds like Mars and even the Earth's moon have cooled to form crusts which are now thought to be far too thick to experience plate tectonics. However, both Venus and the Earth are roughly the same size. They were formed in roughly the same part of the solar system out of roughly the same material. And so, like Earth, Venus should still be geologically active. The question is, why does Venus, which is so similar to the Earth, act so differently? Because of its thick sulfuric acid cloud cover, science's view of the surface of Venus is very limited, and what is seen doesn't show any obvious signs of current geothermal activity such as active volcanism or moving tectonic ridges. However, the planet is riddled with extinct volcanoes, large lava floodplains, and shield fields several hundred kilometres across which show evidence of extinct shield volcanic activity. Venus is also peppered with strange circular structures with concentric fractures known as coronae, which are thought to be caused by mantle upwelling followed by extensional collapse. Among the geologically unique features on Venus are flat-topped volcanoes called phaera, which look like giant pancakes up to 50 kilometres wide and 1,000 metres high. There are also strange radial star-like fracture systems called novae, and unusual radial fractures resembling spider webs known as arachnoids, which are also thought to be volcanic in origin. Venus's high atmospheric surface pressure, which is some 99 times greater than that on Earth, and its extreme surface temperature of 470 degrees Celsius, which is hot enough to melt lead, may be having an effect on the planet's surface geology. The study's lead author, Associate Professor Paul Byrne from North Carolina State University, says these crustal blocks are a previously unrecognized pattern of tectonic deformation on Venus driven by interior motion, just like on Earth. Although different from the tectonics seen on Earth, it's still evidence of interior motion being expressed at the planet's surface. To reach their conclusions, the authors used radar images from NASA's Magellan mission, which mapped the Venusian surface. While examining Venus's extensive lowlands, which make up most of the planet's surface, the authors saw areas where large blocks of the lithosphere seem to have moved, pulling apart in some areas, pushing together in others, rotating and sliding past each other, much like broken pack ice on a frozen lake. Magellan also measured the gravity field of Venus, the subtle changes in the strength of gravity in different parts of the planet caused by different densities of material below the surface. And the authors used this gravity field data to identify a viscous mantle flow slowly churning the crust. In fact, Byrne and colleagues claim the mantle inside Venus pushes and pulls on its surface more strongly than Earth's mantle does on its crust. Scientists already know that much of Venus has been volcanically resurfaced over time, so some parts of the planet could be really young, geologically speaking. And several of the jostling blocks appear to have formed in and deformed these young lava plains, which means the lithosphere must have fragmented after the plains were laid down. And that gives Byrne and colleagues reason to at least speculate that some of these blocks may have been moved geologically very recently, perhaps even up to today. These new observations come in the wake of NASA's announcement of 2 new missions to Venus, Veritas and Da Vinci Plus, as well as a new European Space Agency Venus mission called Envision. To find out more, Andrew Dunkley speaking with astronomer Professor Fred Watson.
This is a very timely piece of research that's just been published by scientists at the North Carolina State University in the USA because of the fact that we've just had the announcement that NASA is going to send 2 probes to Venus later in the decade. But it's been a big question for a long time. Is Venus tectonically active? Does it have tectonic plates like the Earth does? People have hedged their bets either way, I think. Some people say no, some people say yes. And people do provide little snippets of evidence either way, which seem a little bit contradictory. But now we've got, from this research done at North Carolina State, we see some really good evidence, I think, that, and it's certainly the most convincing thing I've seen, that says that while Venus is still, to all intents and purposes, is a dead world because the surface temperature is 460, I think it is, degrees Celsius. It's impossible for any kind of living organisms we know about to live on the surface. Maybe something in the atmosphere. Despite all that, there is some sort of geological activity, but it's different from the plate tectonics that we have here on Earth, which I guess most people are familiar with. Really large chunks of the Earth's crust are kind of solid, but the crust itself is broken up into these very large chunks which slip and slide and cause eruptions and volcanoes and earthquakes. Alpine fault in New Zealand, which is overdue for a Richter 8 earthquake. They happen every 300 years, and we're overdue. That is absolutely physical and visceral evidence of plate tectonics happening on the Earth. What seems to be happening on Venus, and I should explain that this comes from radar imagery. There was a spacecraft whose name was Magellan, a NASA spacecraft that orbited Venus in the very early 1990s. Equipped with radar, and did radar surveys of the surface because, of course, you can't do any visible imaging because the clouds are so thick and opaque. So Magellan mapped the surface. But what is happening now is people are revisiting those radar images because we've now got the most sophisticated algorithms for dragging hidden features out of data like that. And I think that's what's happened. These scientists they've used the NASA imagery, but it is enhanced. And what it shows is a surface that clearly has fragmentation marks in it, where you can see linear features, straight lines looking like fault lines, but they're following a regular pattern, looking almost like a paved area of a street, for example. They're relatively square, these blocks, and it's broken up into these patterns which are much smaller than the Earth's tectonic plates. But the evidence seems to be, because of these marks, that they do behave like tectonic plates, banging into each other and dragging alongside each other and things of that sort. One of the suggestions that's been made is that it's like pack ice on a frozen lake, which is a very nice analogue. And one of the authors, Paul Byrne, who's at North Carolina State, he's quoted as saying, "We've identified a previously unrecognized pattern of tectonic deformation on Venus, one that is driven by interior motion, just like on Earth." He goes on to say, although different from the tectonics we currently see on Earth, it is still evidence of interior motion being expressed at the planet's surface. And by that interior motion, what they mean is the convection currents that rise through the mantle. That's how plate tectonics is driven on Earth. We've got these convection movements in the softish rock that surrounds the core of the Earth, but is underneath the crust. So that's what drives plate tectonics on Earth. And presumably something similar is driving these much smaller plates on Venus.
Yeah. So, I mean, aside from the fact that it's got a runaway greenhouse effect, it's similar in size to Earth, and it's more like us than Mars in that respect. And I suppose if you were able to stand on the surface, the gravity would be not much different to here.
Yes, that's correct.
So everything about it is similar to Earth, except for what's happening in the atmosphere. But we're catching up. We're not far. We're not that far behind. We're working on it. Yeah. We're working on it.
Yeah.
But now I'm wondering what's happening on the inside and how similar that is to what we are experiencing on Earth.
So that will be the next step, to try and explain why there's this difference in the tectonic activity. Something we have known, and in fact I wrote about it in the new kids book, that Venus's surface is volcanically active, perhaps until recent times, and in fact even now. We don't know that, whether there are active volcanoes on Venus. People seem to think that they probably are.
Yeah.
But there seem to be major lava flows, which is echoed in what this scientist Paul Byrne says. He says, we know that much of Venus has been volcanically resurfaced over time. So some parts of the planet might be really young, geologically speaking. But several of the jostling blocks have formed in and deformed these young lava plains, which means the lithosphere, that's the crust, fragmented after those plains were laid down. This gives us reason to think that some of these blocks may have moved geologically very recently, perhaps even up to today. So This sort of pack ice pattern is a very exciting thing.
So Venus is most likely having quakes, just like Earth does.
Yeah, that's
and
right.
fairly frequently by the sound of it.
Indeed, that's right.
That's Dr. Fred Watson, an astronomer with the Department of Science, speaking with Andrew Dunkley on our sister program, Space Nuts. And this is SpaceTime. Still to come, planet Earth hit by a powerful Xclass solar flare, and a Russian Progress cargo ship launches to the International Space Station. All that and more still to come on SpaceTime. The Sun has emitted its first X-class solar flare of the new solar cycle 25. X-class flares are the most powerful of all solar flare categories and commonly responsible for the deepest radio blackouts and the most intense geomagnetic storms. The event exploded out of sunspot AR2838, triggering the eruption of two coronal mass ejections, or CMEs. NASA's Solar Dynamics Observatory spacecraft was able to record the blast's extreme ultraviolet flash. Luckily, the area of the explosion had rotated around to the far side of the Sun by the time the coronal mass ejections occurred. However, a pulse of X-rays did generate a rare magnetic crochet, ionizing the top of Earth's atmosphere, causing geomagnetic currents to flow between 60 and 100 kilometers above the Earth, producing a radio burst, an ionospheric disturbance, a surge of electrical currents in the ground, and a deflection of the local magnetic field. It also caused a shortwave radio blackout over the Atlantic Ocean, with unusual propagation effects below 30 megahertz. Unlike geomagnetic disturbances, which arrive with coronal mass ejections days after a flare, a magnetic crochet travels at the speed of light and so occurs while the flare is in progress. They tend to occur during fast impulsive flares like this one. This was the first X-class solar flare since September 2017, and the first of the new solar cycle. During the previous solar cycle 24, some 49 X-class solar flares were produced during the cycle's 11 years. This is SpaceTime. Still to come, a Russian Progress cargo ship docks with the International Space Station. And later in the science report, the Antarctic records a new record high temperature. All that and more still to come on SpaceTime. A Russian Soyuz 21A rocket has successfully launched the 169th Progress cargo ship, carrying almost 2.5 tons of supplies to the International Space Station. The mission from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan lifted off as the space station was flying 400 kilometers above Argentina. The Progress MS-17 docked with the orbiting outpost 2 days after liftoff.
We just heard confirmation that the vehicle is on internal power, and there's the retraction of the first umbilical. Second umbilical has been detached and the launch command has been issued. The engines are starting, turbopumps coming up to flight speed, maximum thrust, and liftoff of the 78th Progress resupply vehicle en route to deliver over 3,600 pounds of cargo to the International Space Station. Everything being reported as nominal or going well so far. First and second stage engines confirmed to be working as planned, continuing to receive all nominal calls. First stage continues to burn. Roll, pitch, and yaw are nominal. First stage separation. The strap-on rocket boosters falling away, and Progress 78 continues its journey. All data for the spacecraft still looking nominal or normal, now about 2 minutes and 40 seconds into flight, and shroud jettison has been confirmed. Everything's still looking good for Progress 78, destination International Space Station. The second stage continues to perform as planned. All data is looking good for Progress 78 and the Soyuz 2.1A booster. The second stage continues to perform well. That second stage Separation confirmed with second stage shutdown and separation. The third stage skirt was jettisoned prior to third stage ignition, which will continue until 8 minutes and 46 seconds after launch. The third stage engine is performing as planned, about 3 minutes left in its burn time ahead of spacecraft separation and insertion to the Progress 78's preliminary orbit. Launch through spacecraft separation itself being controlled at the blockhouse in Baikonur, and that will be taken over by the Russian Mission Control Center outside of Moscow upon spacecraft separation. About 1 more minute left in the third stage burn. Flight going as planned for Progress 78, and just a few seconds until we will stand by for third stage shutdown and spacecraft separation. We have confirmation of third stage shutdown, Progress separation, Progress 78 now flying free. Solar arrays now unfurling. All of the appendages performing as expected on the rocket. The Russian Mission Control Center in Koryov outside of Moscow. This team now has flight control of the vehicle. Progress is now in its preliminary orbit, traveling at about 17,500 miles per hour, and those pre-programmed engine firings will raise its altitude to match the International Space Station.
Because of a persistent air leak in the PRK chamber in the aft port of the Russian Zvezda service module, the Progress MS-17 was instead docked onto the orbiting outpost Poist Zenith port. The supply ship is loaded with some 470 kilograms of fuel, 420 litres of water, more than 40 kilograms of oxygen, and more than 1.5 tons of other supplies, including food, clothes and personal items. At the end of October, the Progress MS-17 will be moved to the Earth-facing or Nadir port on the new Nauka module, which will replace the existing Pirs docking port, which is due to be detached and deorbited on July the 23rd, becoming the first permanent International Space Station module to be decommissioned. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. The World Meteorological Organization has recognized a new record high temperature for the Antarctic, confirming a reading of 18.3 degrees Celsius, 64.9 degrees Fahrenheit. The record-breaking high was reached at Argentina's Esperanza Research Station on the Antarctic Peninsula on February 6, 2020. The Antarctic Peninsula is among the fastest warming regions on the planet, increasing in temperature by almost 3 degrees Celsius over the last 50 years. The previous verified warmest temperature in Antarctica was 17.5 degrees in March 2015. The Earth's average surface temperature has now increased by about 1 degree Celsius since the 19th century, enough to increase the intensity of droughts, heat waves, and tropical cyclones. A new study claims lower levels of ultraviolet B wavelength light has been linked with higher levels of bowel cancer. The findings, reported in the journal BMC Public Health, is based on a study of people of all ages living in 186 countries. The study's authors found the link was stronger for people aged over 45 and remained significant after other things were accounted for, including skin tone and smoking. Ultraviolet B light, or UVB, is important for the synthesis of vitamin D3, which helps to absorb calcium and is also known to be associated with a greater risk of bowel cancer. The authors think the lower UVB may be decreasing levels of vitamin D3. However, they note that other factors were left out of the study, such as any advantage in taking vitamin D supplements. The Pentagon has awarded Raytheon a $2 billion contract to develop a new air-launched long-range standoff nuclear cruise missile. The new weapon will replace America's existing AGM-86 air-launched cruise missiles, which first entered US service in 1982. The US Air Force plans to obtain at least 1,000 of the new missiles, which could be launched by both B-52s and the new generation of stealth bombers, such as the B-21, which is now under development. A Swedish court has struck down a plea from Chinese telecom giant Huawei, which had challenged the banning of its equipment as part of Sweden's 5G rollout. The administrative court in Sweden ruled that the decision by the Swedish Telecoms Authority PTS to ban the use of equipment from Chinese companies Huawei and ZTE on national security grounds was legal. The court found that Sweden's security was important and only police and the military have the full picture when it comes to national security of Sweden. Sweden became the second country in Europe after the UK to explicitly ban Huawei from almost all of its 5G network infrastructure because of concerns over national security. The United States and Australia have already banned Huawei over national security concerns. Meanwhile, Beijing's warned Stockholm that Sweden's decision could have consequences. Well, it was once the realm of science fiction, but the world of Star Trek and the ability to instantaneously speak and understand foreign languages thanks to a universal translator is becoming a reality. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Yes, well, it's a practical application of Google's translation technology applied to mobile phone calls in real time. So Optus, the Australian number 2 telco, has launched Call Translate Beta. Obviously, it is designed to translate phone conversations between different language speakers in real time. Now, you do hear a little blip blip as the translation is happening, and then what you've said has been spoken into the other language by a computer voice. And there is a message when you first establish the call that tells the person that is receiving the call that the service is being done using the Optus Call Translate service. It's currently available in 10 languages: Arabic, English, Filipino, Greek, Hindi, Italian, Mandarin, Russian, Spanish, and Vietnamese. But of course, they're going to expand it to many more languages because if you get the Google Translate app on your phone, you can see it works in almost every language on Earth. Some of the more obscure languages do still sound like Stephen Hawking or Dr. Spitzer, if you remember the old creative sound cards. It's got that very artificial sound. But the voices for languages like French and Russian, Italian, Greek, Spanish, I mean, all of that,
What
Chinese.
about Klingon?
I don't think Klingon is there. But if it was, it would sound incredibly realistic. I mean, the ability for the computer to sound so human is just uncanny. And it's even the same with Siri. I'm testing iOS 15 beta, and the voices are just very, very natural. So Google has also shown that in the US it's got a system that can answer calls and make calls for you and have the Google Assistant talk to the person and book a table. So I guess it's an extension of that. That service hasn't launched in Australia, unfortunately. And to try the Google Call Translate, there is a wait list. So you have to go to optus.com.au/call translate as one word, no spaces, and you can join the beta waitlist. Only one of you has to have Call Translate activated, and once switched on in the My Optus app, you can make and receive calls as normal. But as I said before, both you and the other person will hear the message that the call is being translated, and this is something we'll see all of our phones and technologies do. I mean, there will come a point where this language translation is completely natural and instant, and it will be that Star Trek future of universal translator, or the Babelfish, if you are a fan of the Hitchhiker's Guide to the Galaxy. And we'll take it for granted. Language barriers will be completely eliminated, and we're very close to that happening now. I show a lot of people how Google Translate works, and I've shown them for a decade, and they're amazed. They're amazed that the camera can translate foreign languages into English or vice versa instantly. It enables people to read what's on packets of food from an Asian supermarket, for example. You can see what the ingredients are. Often there's a little translation sticker stuck to it to the back for the nutritional info. But it's really quite incredible, and no doubt this will be copied by all of the telcos, and it'll just be a standard feature. I mean, already there's Google Translate and iOS. Apple has a translation app as well, and Apple showed off some similar kind of advancements for this natural conversation of two people speaking. But Google's been doing it for years.
There's a test for that, isn't there, where you're tested with a person at the other end of the phone, and you've got to work out whether it's a real person you're conversing with or a computer.
It sounds like a 21st century version of the Voight Camp test from Blade Runner to figure out whether you're talking to a human or a replicant.
Blade Runner was a great movie. Now, it's not the only bit of news from Optus this week, is it? They've broken their own record.
Yeah, this is the upload speed record on a commercial 5G network. They clocked in 300 megabits, and this was achieved on Optus's 5G millimetre wave site in Strathpine in Brisbane in the Australian state of Queensland. And this millimetre wave, wave technology isn't switched on to the public yet in Australia, but it will be soon. The next iPhones for 2021 are sure to have wave 5G, as they already do with the iPhone 12 in the US, and as various Android devices have. Wave allows 5G to achieve the kind of promised speeds that we heard about 5G. At the moment, 5G speeds that are not using mmWave are a bit more like super fast 4G, like 4G on steroids. But this mmWave 5G can do much faster speeds. And normally when I'm uploading with 5G, I notice that its upload speeds are much slower than the download speed. So to get 300 megabits is good. And an example that they've given is that if you have a 500 megabyte video file on current 4G networks, it'll take about 1 minute and 30 seconds to upload, which is already fast. We can't complain about that. But with 300 megabits of speeds, they say that task can be completed in less than 20 seconds. So next iPhones and the next Androids that have 5G millimeter wave on the various bands for the country that you're in, when they connect to that, you're going to see things like your Zoom calls when you are sending a picture to somebody else. The video will be sharper and clearer because upload speeds will be able to match or be a lot faster than the upload speeds of today. I mean, we're talking 10 times faster or more, depending on the sort of upload speeds you're getting now. A continued journey towards the Star Trek-like future that seems to be becoming science fact every day.
Engage. That's Alex Sahara-Royd from ITY.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.